Hi algebra students, please find your 4.1 and 4.2 exponents, adding and subtracting polynomials template. This is a little cut off because of the hole punch. This should say 5 to the 4th. So this represents the repeated multiplication of 5 times itself 4 times total. Just a reminder of some of this vocab. 5 is called the base. This is the number you multiply. 4 is the exponent. This is the number of times the base is used as a factor. And this is our generic kind of formula here. Okay? And that's how you would say it. B to the n is the nth power of b. What you don't want to do is you don't want to fall into the trap that a lot of students do and think that these are multiplied together. Exponential form is the result when all like bases are multiplied together. So the example we have here would be 4 times 4 times 4. In exponential form would be 4 to the 3rd power. Replacing each variable in the expression by a given value and simplifying the result is the definition of evaluating. And for simplifying, you're going to simplify all expressions within grouping. Symbols, just a reminder, those are parentheses, they can be brackets, they can be absolute value bars. And we're going to compute all possible operations using order of operations. And you're going to combine all like terms. The ultimate rule is simplify, then classify. If I had to pick one thing that you probably want to do a brain dump on the top of your quizzes or tests when you get them in this unit, it would be that. Definition of monomial is at the top. This is something that you studied in Chapter 4 of pre-algebra. A monomial is an expression that is a numeral, a variable, or the product of a numeral or one or more variables. So basically it could be, let's fill in some examples. We could have a constant like 4. We could have the product of a constant and a variable, 2a. You could have more than one variable, so 3ab. You could also fill in 16x minus 16x because when you do that math, you get 0, and therefore it is a monomial. Non-examples would be something that are more than one term. So like 2a plus 4, that's 2 terms, that's not a monomial. X squared plus 1, not a monomial. A polynomial, poly the prefix meaning many, is a sum of monomials. Binomial is when we have a polynomial with 2 different terms, the prefix bi meaning 2. Trinomial, the prefix tri meaning 3, is a polynomial with 3 different terms. So some examples of those would be for binomial, we could have 3x minus 10. We could have 6ab plus b squared. We could have 4x squared plus 2x plus 6x squared. Following the rule, simplify before you classify, these are like terms, and therefore we can combine them to get 10x squared plus 2x, and that is a binomial. For the trinomial examples, we're going to have things like x squared minus 4x minus 5. They are 3 different non-like terms. You could also have 2a squared plus 3ab minus 4b squared. That's a trinomial. And you could also have 6a squared plus 2ab plus 4a plus 6ba. These two terms are like terms even though the variables are in a different order. By commutative of multiplication, they could both be a, b, or ba. We can combine them, so 6a squared stays the same. This becomes 8ab, and this becomes 4a. In a doubt or in a pinch, we always put the variables in alphabetical order. We're also going to study something called the degree of a variable in a monomial. And basically the degree is the number of times that the variable is used as a factor. So diving into some examples, x to the fifth has a degree of 5. It matches the exponent there. 12, or any constant, has a degree of 0. 0 is special though. It has no degree. And you don't want to confuse that with 0. It does not equal 0. You actually say the phrase no degree. It's like when we talked about no slope and 0 slope that are two different things. Now take a look at the degree here. We've got two exponents, two variables going on in one term. What you do is you add them. So this has a total degree of 5. Now when you look at the degree of a polynomial, you want to pick the degree that is highest of however many terms there are. So for this one, the highest degree is on this one because it has a 2. So the degree of the whole thing is a 2, even though this has a degree of 1 and this has a degree of 0. You pick the highest one. In the middle here, we've got a degree of 2 coming out of here, a degree of 1 plus 2, which is 3, and a degree of 2. We would want to simplify this first because this and this are like terms. So we would look at this as 5x squared plus 4xy squared, and then by the same reasoning, this has an exponent of 1. The degree should be 3 because you add the 1 and the 2. Again, we've got some like terms here. These actually cancel each other out, and you're left with 3. 3 is a constant, so it has a degree of 0 as your final answer. On the back, we're going to take a look at example 1. I'm going to show you how to subtract this polynomial from this polynomial, but you need to be very careful with this word from, because what that means is this guy is the first one, and you're subtracting this, okay? Now to look at it horizontally, what we're going to do is we're going to start with the first polynomial in parentheses. So we actually start with the 3a squared minus 2ab minus 2b squared minus 7, and we are subtracting the first polynomial, the opposite of a squared minus 5ab plus 4b squared minus 2. Now, in order to make this a little bit easier and not to lose track of some negatives, we do want to do kind of a def S here, where I would rewrite the subtraction into plus, but that takes the opposite of each of these terms. So I'm going to rewrite that underneath. We've still got the first polynomial, 3a squared, but I'm going to rewrite some of the subtraction here. I'm going to make this plus negative 2ab plus negative 2b squared plus negative 7. So nothing really changed except rewriting the subtraction. Plus, the opposite of negative a squared is positive a squared. Opposite of negative 5ab is positive 5ab. This becomes a negative 4b squared and a positive 2. Now what I want to do is I want to look at the things that are like terms. And I'm going to start with the ones with the highest exponents. So let's start with 3a squared over here. So I've got 3a squared. We are going to add that to its like term, which over here is the a squared. So following the horizontal method, we are going to write those in the same set of parentheses. Now I'm going to look at the next set of like terms. We've got a negative 2ab in the first set of parentheses and a 5ab here. So again, I'm writing those in the same set of parentheses. Negative 2b squared is a like term with negative 4b squared. So I will put those in the same set of parentheses. and I've got a -7 and a +2. So again, those go in their own set of parentheses. Now I'm just going to combine. So remember that when you add terms, you do not change the exponents. So this is a 3ab, or a 3a squared, pardon me, plus a 1a squared gives you a sum of 4a squared. Plus -2 plus 5 gives me 3. So that should be 3ab. Plus -2 plus -4 is -6b squared. And -7 plus 2 should give me -5. You'll notice that none of these remaining terms are like terms, so this is my final polynomial, and it's got 1, 2, 3, 4 terms. So this would be called a polynomial, and it has a degree of, this has 1, this has 1, so this would have a degree of 2, 2, 2, 0, so the highest power would be 2. So now we're going to look at example 1 with a vertical method here, and by the end of these notes, I want you to be thinking about what method seems to work best for you, and then I would stick with it, because frequently when we ask you to add polynomials, we will allow you to choose the method that you would like to use. So I just rewrote the problem at the top of the screen, but you can just look up further on your page of notes. We still want to set this up as this polynomial minus this polynomial, but we're going to show the work vertically. So what we want to do is we want to rewrite the second polynomial, because we are subtracting that first, plus -2ab plus -2b squared plus -7. So I rewrote my subtraction, and then I'm going to change it to adding, and I am skipping back to this step on the prior slide where we rewrote the subtraction for the second one. So just be careful with those positives and negatives. Plus a squared plus 5ab plus -4b squared plus 2. And again, I'm getting that by rewriting a subtraction problem to addition using the work we did on the prior slide. I didn't want to redo it for you guys. Now what we're going to do is we're going to add these up vertically starting over here. So we've got -7 plus +2 gives me -5. -2 plus -4 gives me -6b squared. -2 plus 5 gives me 3ab. +3, pardon me, plus 1 gives me 4a squared. So you should be seeing that we're getting the same answer as the top, but we showed the work vertically because it's underneath, whereas the prior slide was horizontally. We showed it side to side. So you probably have a preference, and I will say that most students probably enjoy doing it vertically best because they don't have to rearrange the order, which at times can lead to forgetting a term, which is a little confusing. The other thing I would suggest before I wrap up this video is making sure that you bring colored pencils or highlighters or anything to the quizzes or tests or to the practice sessions, because you can always color code these and make them different colors according to like terms, which might be helpful when you're looking at the big scope of things. It might be less easy to lose something if you're color coding it. So just keep that in mind. You're always welcome to mark on your quiz or test and use colored pencils or whatever would suit.